Hello, today we are going to work on surface area of pyramids and cones. There are four warm-up problems here real quick just to get us used to working with radicals one more time. For the first one, you're going to multiply the coefficients and you would get 30. You would multiply the radicands and get 6, and you would ask yourself if 6 broke down anymore. Since it doesn't, that would be your final answer. For number 2, we're working on our 30, 60, 90 triangle, so across from the 30 is the shortest side, that is your n. The hypotenuse is the longest side, it is 2n, and across from the 60 degrees is going to be the longest leg at n root 3. So for this one here, x would equal 4 root 3. For this next one, we have the side across from the 60, which represents our n root 3 side. So to get n by itself, you would divide by root 3, and then you would have to rationalize. And so you would get 9 root 3 over 3, which reduces to 3 root 3, and that would be across from the 30. That would be your shortest side. Then to get your y value, you're going to go ahead and double that to get 6 root 3. And for our last warm-up problem, it's once again across from the 60 here. This is our n root 3, which means n is just going to be 5 for this one, and therefore z is going to be 10. Okay, so now we're going to move on to pyramids here, and we're going to talk about how to find the lateral area and the surface area for pyramids. So looking at these ones, the pyramids are always going to be named based off of whatever base you have. So the base is going to be the shape kind of at the bottom here. Notice that these could actually be turned, so it's not always going to be at the bottom. But all of the other faces are all going to meet at one point. That point is called the apex. That can kind of help you identify the base. It's opposite the apex. The nut of each of these, what we're going to do is we're going to start by drawing the base. And then what you're going to do is you're going to draw each of the other faces coming off of that. So if we're kind of opening these up, we have our base, and then we have all of the other faces kind of opening up, kind of looking like flowers or something like that. You'll notice again the base is in the middle with how we drew these ones. All of the other faces here are called your lateral faces. The petals, if you will, on the flower, those are your lateral faces. So let's go ahead and take a look. I'm going to zoom out just a little bit so we can see all of this together. The height of the pyramid is going to be the distance from your apex down to the base. So the height is the distance from the apex to the base. Depending on what your pyramid, your height could be inside or outside of your pyramid if your apex was kind of way off to the side. We're going to be working with ones that are kind of regular so that your height will be inside here. The slant height is going to be the height from your apex to the lateral edge, or one of these edges of the bases here. So your slant height we're going to show as L. It's the distance from the apex down to the base in one of your lateral sides. Your lateral edges are all of the edges around your lateral faces from your base to the apex. And your lateral faces, we said, were the ones that are around the outside that were not the base. The base then would be the other shape opposite the apex. So we're going to be able to do the lateral surface area and the total surface area. So the lateral surface area is going to be the sum of all of the lateral faces together, the area of all of those. And you'll notice that each of these lateral faces here that we highlighted in yellow is a triangle. So we're going to be using our triangle formula within our lateral area formula. So the lateral area formula, since they are all triangles, it's going to end up being 1/2 the base times the height. Now the base of all of those different, like imagine that this was again your shape here. Okay, we're going to look at a square pyramid. The lateral faces are all of these ones. All of these are triangles. So when we do the area formula for a triangle, we normally do base times height divided by 2. And so your base here would be all of these ones all the way around, which ends up being the perimeter of your base. And then the height of each of these triangles ends up being the slant height of the pyramid. So the lateral area of the pyramid is 1/2 the perimeter of the base times the slant height. The total surface area would be exactly the same thing that we just had, 1/2 times the perimeter times the slant height, but we have to add in this base here. So we want to add in the area of the base. So let's go ahead and try finding the lateral and surface area of a pentagonal pyramid. So we want to go ahead and kind of visualize what that would look like. So we're going to have this pentagonal base. We're going to have an apex up here and all of our lateral edges going down to the base. The slant height is 6. So the height here is perpendicular is 6, and the base edge is 8, which means all of the edges along the base. So in order to find the lateral and surface area, we want to know a couple things. We want to know the perimeter of the base, we want to know the slant height, and we want to know the area of the base. So we actually already know the slant height. The perimeter of the base, we could do 5 times 8 and get 40. So the trickiest thing about this one in particular is finding that area of the base. So let's go ahead and kind of dive into that a little bit more. We have this pentagon here. If we were to draw in this triangle here, that we would draw in this right triangle and it would split that side in half. We would need to find this angle up here. So if we do 360 divided by 5 of these triangles, we would get 72. And if we divide that in half, this angle here would be 36 degrees. We want to figure out what this apothem would be so that we can find the area of this pentagon. So the apothem here, we're going to use SOHCAHTOA. So we're going to do tangent of 36 equals opposite over adjacent. So tangent of 36 equals 4 over A. Solving for A gets us 4 divided by the tangent of 36. And so our area of the base is going to be 1/2 the perimeter of the base times the apothem, which is 4 divided by the tangent of 36. Now we can go ahead and simplify all of this together, or we could go ahead and type this in and get a decimal answer. If we needed it just as simplified, it would be 80 divided by the tangent of 36. But what we'll do is we'll go ahead and use just an approximate answer. We'll use 110.11. And we can type that in on our calculator and store that as B if we would like. So now we have all of our important information. It's just a numbers game now where we plug everything in. So our lateral area, we'll think back to that formula, is 1/2 the perimeter of the base times the slant height. So our lateral area here is 120 units squared. Our total surface area is going to be what we just got with the last one, 1/2 the perimeter times the slant height, plus the area of the base, which we have stored from up here. So this is going to be approximately 230.11 units squared. Okay, so let's go ahead and take a look at cones now. Now, cones are pretty much just like pyramids. It's just that their base is a circle. They're the same thing though. So our lateral area is going to be similar. We're going to go ahead and do 1/2 the perimeter times the slant height, but our perimeter here is the circumference. So if we were to do 1/2 of 2 pi r times the slant height, it's going to simplify a little bit. So it's just going to be pi r l. For the total surface area, you're going to take your lateral area, which is pi r l, and you're going to add the area of the base, which is pi r squared. So these are our two formulas for our lateral area and our total surface area. Let's try an example here. So you notice here we actually have our radius given to us, that's 5, and we also have our slant height given to us, that's 16. You'll notice that if we didn't have the slant height, but instead we had the height of the cone, we could use the Pythagorean theorem to find the slant height. So to find the lateral area, we're going to do pi RL, and our lateral area would end up being 80 pi units squared. We also then can find our total surface area by taking our lateral area and adding on the area of the base, which is pi r squared. When we end up doing that, we get 105 pi units squared. So let's take a look at the next one. It says find the lateral and surface area if the slant height is 12 and the height is 6. So here our slant height is 12 and the height of the cone is 6. So we can go ahead and find our radius here. There's many different ways to do that. This is a right triangle, so you can use the Pythagorean theorem, or you can notice that with the right triangle here, one side length is double the other, which is going to make this a 30, 60, 90 triangle because the one that's double is your hypotenuse. Either way, when you do the Pythagorean theorem or look at that, you're going to get 6 root 3, and it would be a 30, 60, 90 triangle. So then to find our lateral area, we're going to do pi r l, and we're going to simplify all of that. So we're going to end up with 72 root 3 pi units squared. And if we want to get a decimal approximation, it would be about 391.78 units squared. So our surface area would be 72 root 3 pi, it's our lateral area, plus the area of the base, which is pi r squared. And so this would end up being 72 root 3 pi plus 108 pi units squared. This would be the exact answer. We can't combine those because they're not like terms. If we wanted a decimal approximation, it would be 731.07 units squared. Okay, let's go ahead and take a look at another one. Find the area of a regular pyramid. So that means all of the faces are congruent, that has lateral edges of 8 centimeters. So this regular pyramid is going to end up being a triangular pyramid. And so each lateral edge is going to end up being 8. So this one you can do all of your different formulas, but we also can use what we know about surface area just being the sum of the areas of the sides. So looking at this, each side has to be an equilateral triangle. So the area of each base here is going to be s squared root 3 over 4. And so each face here is going to end up being 16 root 3. And so since all 4 faces are going to be congruent, we can take and we can actually find our total surface area by just multiplying this by 4. We would get 64 root 3 centimeters squared for our total surface area.